Hello everyone, welcome to my channel Middleware Technologies. Today we'll be looking at how we can use GPG keys in order to sign and encrypt our data. Okay, so here in this video, we will be using the GPG tool, which is an open source tool, in order to do a secure communication between two users. Okay, so we'll be trying to set up GPG keys, which we'll be using for signing and encrypting our data before that data is sent to the other user for secure communication. So basically GPG keys are used for making our data secure or encrypted in such a way that the other party is able to identify who is the sender of this data, so that we can authenticate that the data has been coming from the intended party, and also he is able to ensure that the data is encrypted so that he is the only one who is able to decrypt this data. Okay, so let us see how we can achieve this in this video. So I am currently working on Fedora 39 and 38 instances. So you can work on any of the Fedora instances. The only thing that is required is you need to have the GPG key, the GPG tool installed on your machine. Okay, so currently I have 2 instances of Fedora which I am currently working on. Okay, so let us try to understand what is GNU-PG. Okay, so GNU-PG, also known as GPG, is an open source tool that is provided for us to encrypt the data, encrypt and sign the data that we want to securely communicate with the other party. Okay, so it is an open source implementation of the OpenPGP standards. Okay, so this is a very basic short explanation about what is GNU-PG. Okay, so let us try to explore more about this tool by actually doing some exercise. Okay, so as I said, I have 2 virtual machines right now which are Fedora instances. So let me show you. So this is my first machine, that is Fed Research 1, and this is my other machine, that is Fed Research 2. Okay, so on Fed Research 1, I have user Alice, with which I'm logged in, and on Fed Research 2, I'm logged in with the user Bob. So as I said, the first and foremost thing that is important for you to work with GPG is you need to have the GPG tool installed on your machine. So you can just check. So you can see these are the GPG packages that are available on my machine, but the core package which you need to install, you can check with. So let's say if I search for look for GPG, so it will show me this file. So let me grab the package corresponding to this utility. So this is the GNU-PG package that you are supposed to have on your machine in order to work with the GPG utility. Okay, so this is present on both of my machines. So if I go and do the same thing on Fed Research 2, I will get the same package. Okay, so that is what you need to have before you start working on this tutorial. Okay, so first thing is setting up your VMs with the required tool in order to work with GPG. Okay, so now let us go into our next step, that is generating the key pair. Okay, so as I said, GPG is used for encrypting and signing your data. Okay, so this encryption and signing of the data is based on public cryptography technology, which basically uses the public and private keys in order to sign and encrypt your data. So we will see like how and which keys are used for signing and encrypting the data before that is sent to the other parties. Okay, so before that, first we need to generate the keys for each user. Okay, so let us try to generate the GNU PG keys, that are public and private keys, for each user. Okay, so the command that we need to use is GPG full generate key. So it will basically it will ask for a few details. The details will be pertaining to the key and the user. Okay, so the first details that we are going to provide to the full generate key command is the key details. Okay, so first thing that it asks us is to select the type of the keys that we want to generate. Okay, so I will select RSA and RSA, that is first thing. So it basically generates two set of key pairs of type RSA. One is for encryption and other one is for decryption. Other one is for signing. Okay, so let us select the option 1 and proceed. Okay, so the next thing that is that it asks is the key size. Okay, by default, like let us try to go with 3072, which is like the more the number of bits for the key, like the higher the security or the higher the entropy for generating the unique keys. Okay, so let us go with 3072, the default one, and proceed. Okay, now the next thing it asks is like how many days or how many years you want the key to be valid. Okay, so basically we are going to provide the expiry date for our key. Okay, so now let me go and give the expiry as 1 year. Okay, so it is asking whether this is correct. So let us give it the answer as yes. Now like the key details that we wanted to provide are all done. It comes now to the second part, that is providing the username details. So here like we need to provide the username. So I'm currently working with the Alice user, so let me provide the username as Alice and the email address as alice@stack.com. Okay, now in the comments, like you can just give Alice, and the last thing that is it confirms is whether the user ID that it's generated is the one that you want to use or you want to modify anything in that user ID. So let us keep it the same, so we can select OK. And now the important thing is we need to secure our keys or the private key using a passphrase. Okay, so let me give the passphrase. Okay, so now the passphrase is provided and it has generated our keys and it has saved the revocation certificate. So in case your private key gets compromised, like you need to like submit or like revoke your keys using this following key revocation certificate. Okay, but now let us see the things that got generated. So there is a public key, okay, there is a subordinate key, and there is a user ID that gets generated. Okay, so public key is a primary, so it is basically the primary key pair, and subordinate key is basically the key that is used for encryption. Okay, and both of them, like you can see, are RSA type of keys with 3072 as the key size, and user ID you can see like it is alice@stack.com. Okay, so these are the same details that we have provided while generating the key. And you can see the expiry is 1 year from now, so this is 2024 11 18 on which it is going to expire. Okay, so this key is generated. Like, you can just list your keys using GPG list keys. So you can see, let me clear my screen, and you can see like it has provided the keys that are available on our machine, like you under this keyring database. Okay, so now let us go to Bob user and try to generate the same set of keys, that is GPG keys, on this machine. Okay, so now let us do GPG full generate key. Okay, so now here, like, also, like, you will need to select the key type. So let us select as the first option key size. Let us keep it as default. The key expiration date, put it as 1 year. Set it as correct. Real name, like here it is going to be Bob, for which we are generating the keys. Address is bob@stack.com, and the comments in Bob, and let us proceed with saying OK to generate the key with the following name. Okay, so let us provide the key name. Okay, I think I have given incorrect passphrase first time, so let me try to generate it again. So real name is Bob, email address, comment is Bob. Okay, so now the key pair is generated for the user Bob. Okay, so you can just clear the screen and do GPG list keys, and you will see your keys generated. Okay, okay, so now that we have the keys generated for you, the two users, let us go to the next step which we want to do. So now we have generated our keys. Let us go into our next step, that is step 3. So one more thing that I wanted to mention over here is the code. Okay, so you can see these codes SC and E. So as I said, like, there are two key pairs that got generated in this, like using the RSA technology or RSA cipher or algorithm, you can say. So first thing is S basically means signature. So the key is going to be used for the signing. Okay, and the other one is like generating the certificate. So the key can be used for generating the certificate also. Okay, so as you can see, like, this public key is GPG public key can be used for generating the signature, signing, and for generating the signature certificate. And the other one is basically E. It means it is going to be used for encryption. Okay, the subordinate key is going to be used for encryption, and the other code character is A, which can be used for authentication. Okay, so these are the some character key constants which will be handy for you to understand basically when you are generating the keys. Okay, now let us go into further into our next step, that is exporting the public keys. Okay, so now that we have the keys generated for each user, like there is going to be a public and private key. So in order so we need to extract the public key out of that keyring database. Okay, so we have seen like how we can list the keys. So it basically goes and fetches the data from the keyring database. Okay, now like we are going to export the data explicitly so that we can get that public key shared with the other user. Okay, so now what we are going to do is we are going to run this command. So it basically outputs our public key into this file. So we are exporting the Alice user ID or the user's public key. Okay, and the option armor is basically to generate the data or the key in a JPG format or the ASCII format which is readable. Okay, so let us try to run this command. So let me okay, so I have some things already present, so let me clear those things. So let me delete all of them. Okay, so I'll just delete all of them, and here also let me do RF so that I delete everything. Okay, so now it is clear. So let me run that command again in order to export our public key. Okay, so now you can see the public key of user Alice has been exported to the file alice.jpg. So you can see alice.jpg is generated, and if you look at the content, so it is going to be in a readable format, which is basically what we have done by passing the armor option. So in case like you are not sending the armor option, like it is going to generate the keys, generate the key in binary format. Okay, so let me clear my screen. So now we have the alice.pgp present, and let us go and do the same thing on the user on the machine for user Bob. Okay, so here also we are going to export the public key for user Bob using the same command, and now the bob.jpg file is generated. So if you cat the file, so you're going to see the public key for the user Bob. Okay, so now that we have the public keys generated, we need to share this public key with the other user. So let's say here, like I want to send a secure data from Alice to Bob. Okay, so first thing that we need to do is we need to share the public keys. Okay, so let us now share the public key, that is Alice public key with Bob, and here like we are going to use the SCP tool for securely transferring the file, that is the public key, to Bob. Okay, so before doing that, so let us try to see, like we have generated exported the public keys, like we need to copy them using SCP. So this is the command that we can use. So it basically copies the alice.pgp file to the machine Bob at the following location. Okay, so let me copy this one. So the file is copied. Now let us do the same thing with the Bob GPG. We are going to send it to alice@research1, and the location will be home/alice. Okay, so that the keys, the public keys are copied. So now if you do ls-ldr, you will see the Bob public key present on the Alice machine, and on the Bob machine, like you will see the Alice key, that is public key, on the Bob's machine. Okay, so now let us go into our next step, that is importing the public keys. Okay, so this is very important. So basically, like once you have shared the public keys, it is important for us to import that public key into our keyring database. Okay, so as I have shown you, like whenever we have generated the keys, like it is going to store our public key in a keyring database. Now we are going to import this public key of the other user into the same database. Okay, so how we are going to do is, we are going to use the following command, that is gpg import Bob's public key into our keyring database. So it is going to like say that. Okay, so I think I'm on the same machine like where the Bob key pair is generated, but this needs to be executed on the Alice machine. Okay, so let me clear my screen over here, go to the Alice machine, and here like we need to import the Bob key into the keyring database that we generated for Alice. Okay, so now you can see the key has been imported. Okay, if you now do the gpg list keys, you are going to see two keys now. Okay, so the first key is the Alice key, that is like key that is generated by us, which consists of a private key and a public key, and the other key is going to be for the Bob. This is going to be only the public key, okay, that we are exporting into the keyring database. So this is the keyring database into which the public key is imported, and you can see like this status shows as unknown. So it basically means the public key that we have exported is right now unknown. Okay, so similarly, let us try to do the key import onto on the Bob machine for the Alice key. gpg import, and here we are going to import the alice.gpg key. Okay, so the key is imported. Now if you do gpg list keys, it is going to show you the Alice public key, which is unknown. Okay, with the status unknown. Okay, we will try to see like why the status is unknown. So basically the status unknown means the key is not like known or signed basically. Okay, so GPG keys work on the concept of trust model, way of trust. So basically like every key that is generated has a fingerprint. Okay, so let us try to do GPG fingerprint. So it is going to provide us with the key in the following format. So it is basically like the same key but in a chunk of 4 characters. Like it is going to show the key the fingerprint of that key. Okay, so now so as I said, like it basically GPG works on the trust model. So let us say like this key, okay, that we generated over here on this Bob machine. Okay, so currently we are on the Bob machine, and the key fingerprint for Bob is this key. Okay, so this is what, like, we need to ensure that whatever key we are going to sign on our machine, like, so this is Alice machine, and we have imported the Bob key, and currently the status is unknown, but we want to make sure that we trust this key. Okay, so what we need to do is we need to match the fingerprints of the key that we have imported. Okay, so now you can see the fingerprint of the Bob is ending with 491D, B2B5, B8A8. So the key that we generated on Bob machine is also ending with 491D, B2B5, B8A8. So this ensures that the key that we have received from Bob is actually the same key that we are going to trust. Okay, so now we are sure that the key that we got is from Bob, and we can sign this key. Okay, so we need to do sign key Bob. Okay, so it will be asking, are you sure that you want to sign this key with your key, that is Alice? Okay, so let us say yes, and it is going to ask for Alice key, that is private key, which is going to be used for signing the Bob's public key. So we need to provide the Alice key passphrase. Okay, so now the key is signed. If you go and do list keys again, you will see it has changed the status from unknown to full for Bob. So it basically means, like, we have signed the public key of Bob and we trust it. Okay, we trust it based on the fingerprint that we have received. Okay, now let us try to do the same thing. Let us go into our Bob's machine. So here, if you see list keys, right now the Alice key that we have imported over here is unknown. So let me generate fingerprints, and the Alice key that we have imported is ending with 80A8 8C5E FD22. Okay, now if you go into the Alice side, like, you can just check the fingerprints for Alice key. It is ending with 80A8 8C5E FD22. So it is the same key that we have received, so we can trust it. Okay, so let us sign this key using the Bob's private key. Okay, so let us say yes. So we want to sign the Alice key with Bob private key, and let us provide the Bob's passphrase. So now this key is signed. So let us do list keys, and you can see the key is signed and the status has changed from unknown to full. Okay, so this is how, like, you can trust your keys, like that you have received. Make sure, like, you are going to match your fingerprint of the key that we have received before you sign the keys. Okay, so that is very important. Okay, so we have seen how we can import the keys. We have and the next step, that is step 5, we have signed the keys. Okay, so the important thing to note over here is, you can see this step,
statement. Key verification is a weak point in public key cryptography. You should be extremely careful and always check the key's fingerprint with the owner before signing the key. So that is what we have done. So we have verified the fingerprint of the key that we want to export, that we want to import into our database. Before like importing the key fingerprint, like we need to ensure that the fingerprint is validated with the owner of the key. Okay, so this is very important that you need to carry out. So now let us go into our next step, that is step 6, creating the document. Okay, so this is going to be our document that we want to send it from Alice to Bob in a secure manner. So let us try to generate this document first. Let us go into our user Alice machine and generate this file. This is a secure document that needs to be sent to Bob and save it into send to bob.txt file. Okay, so now that this file, like we need to send it to the Bob in a secure fashion. Okay, so the first thing that we need to do is we need to sign the document. Okay, so basically, like when we are sending something to somebody, okay, so how do we ensure that this document is sent by us only? So that is where like the signing comes into picture. So basically, like when we sign the document, like we are telling the other party that this document is that this document source is from the party that the other party is expecting the document from. Okay, so so here like we are going to sign this document using the Alice private key. Okay, so that the when the other party is going to like extract or decrypt the document, he is going to validate whether this document has been signed by the Alice by using the Alice public key on his database. Okay, on his keyring database. Okay, so let us see like how it happens. So we need to run this command. So here like you will see we are going to output the file into this like the signed document. So it is basically signing the send to bob.txt file and outputting the signed document into this send to bob.jpg file, and the output is going to be generated in the ASCII format. Okay, so let us run this. So now like this file is like signed using the Alice private key, and we have generated this signed document. Okay, so now that we have signed the document, the next thing that we need to do is we need to encrypt the document. Okay, so basically like the sign we need to ensure that the document that we are sending is going to be like decrypted only by the intended user. So here like we are sending the document from Alice to Bob. Okay, so only Bob needs to like basically decrypt this document. So for that we need to encrypt it. So right now like we have like encrypted like we have signed this document using the Alice private key. So this document, if we are going to send it as it is, like anybody can verify the signature or decrypt the document and get the document. So that is not we want it to happen. So once the document is signed, we need to encrypt that signed document so that only
So this encryption is going to happen with the public key. So whose public key? So let us say like you want to send this document to Bob, so you need to encrypt this document using Bob's public key, so that only Bob's private key is going to decrypt this document. Okay, so now let us try to encrypt the document. So here like we are going to use this following command, wherein like we are going to encrypt, save the output into this file, and encrypt for the recipient Bob, and the file that we are going to encrypt is this signed document. Okay, let us run this command, and now like your encrypted file is ready and you cannot read this file. Okay, so this file can only be read by Bob, who has the private key for this document which has been encrypted using the Bob's public key. Okay, so now let us send this document SCP send to Bob encrypted file. That this document we want to send it to Bob, so we are going to use SCP as a manner in order to send this document, but there are other ways in which we can send this document. Okay, so now let us send it via SCP for this demo. We are going to send it to the home directory of Bob. Okay, so now the document is sent. So here let us go into our Bob's machine, and you will have this send to Bob encrypted file available. Okay, so now like we have done the encryption. Okay, so we have done the encryption and we have sent this document to Bob's machine. So the next step is now step 9, that is decrypting the document. Okay, so the first thing is like we need to decrypt the document. Okay, so only Bob can decrypt this document because he is the person who is holding the private key for this document. Okay, so now let us try to decrypt this document using the Bob's public key. So you can see like we are going to decrypt the file and send it to this following file. Okay, so let us try to decrypt it, and it will show encrypted with the following key or ID, user ID, key ID. Okay, so this was encrypted using the Bob's public key, so it shows it was encrypted using Bob's public key and it is able to decrypt it. Okay, now you can see the send to Bob text file is decrypted, but still you are not able to see the document, okay, that we have sent, because we have just decrypted the document, but it is still in the signed format. So we need to verify the signature and extract or decrypt the signature now. Okay, so now what we need to do is first we need to verify the signature. So let us do GPG verify, and you can see this signature is good, like it has been signed by Alice, private key, which is fully trusted, so it is a good signature. So now you can just extract the document out of this signature using the following command, that is outputting the document into send to Bob decrypt send to bob.txt file. Okay, so now you can see the signature is verified and the document has been decrypted. So if you go and see the decrypted file, you will see the document that you have sent
from Alice to Bob in the same with the same content. So this is how you will be able to use GPG keys in order to securely communicate your data from one party to another. Okay, so this is a long story how we can use the public and private keys of each user to sign and encrypt the document before they are sent to the other parties. But there is an easy way you can do this activity. So let us try to look at that easy way now. Okay, so now let us go into our easy way. So here let me try to generate another document on the Alice machine. So here this is going to be the document, the secret general that we want to send it to Bob. Okay, so now let us try to sign and encrypt this document using the following command. So here we are going to pass these two options, that is sign, encrypt and sign, and we want to generate the output in the ASCII format, and the recipient is going to be Bob, to whom we want to send this document. Okay, so let us try to run this command, and this is going to sign and encrypt the document. So if you look at this document, so this document is now signed and encrypted. Okay, let us send this document using SCP to Bob's machine. Okay, so now the encrypted and signed document is sent to Bob's machine. Sorry, I need to send the .asc file. So let me send this encrypted file over here, and here let me delete the unencrypted file that we have sent. Okay, so now you can see the encrypted file is encrypted and signed document is available over here. So the decryption for how we can extract basically decrypt and verify the signature is just doing the GPG on that file. Okay, so you can see it mentions the file has been encrypted using the Bob's public key, and it has been signed using the Alice private key, which is a valid key. Okay, so if you go and do ls-ltr, your unencrypted and verified document has been extracted, and if you see the content, so this is the secret general that you want to send. This is the same document that we have created over here, and we have signed and encrypted and sent to Bob. Okay, so this is the easy way that you can use the keys in order to sign and encrypt and send it to the other party. Okay, so this is all I wanted to show you in this video. I hope you enjoyed watching this video. Thank you all. Thanks for watching this video, and you guys have a great day.